Okay, welcome to Geometry Triangle Congruence Theorems. Okay, congruent triangles have three congruent sides and three congruent angles. What that means for us is that we would have to show all three sides were congruent and all three angles were congruent. That gets to be a lot to do when we're trying to work these out. So we do have triangles can be proved congruent without showing three pairs of congruent sides and three pair of congruent angles. We can use just a combination of sides and angles. Here's the big picture for all triangles, the triangle congruence postulates and theorems. These are the four main ones that we're going to use. We're going to have the side, 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 angle, side, angle, side, angle, and angle, angle, side. And then we have some for right triangles only as well. However, they are just variations of side, 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 angle, side, angle, side, angle, and angle, angle, side. And those are the hypotenuse leg, 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 hypotenuse angle, and leg angle. If two angles in one triangle are congruent to two angles in another triangle, then the third angles must also be congruent. Think about it. They have to add up to 180. Here's an example. If two triangles have two pair of congruent angles, then the third pair of angles is congruent as well. So what we're looking at here is if we're seeing the 85 here and the 30, that's going to add up to 115. And because the angles in a triangle have to add up to 180, that's going to give us 65 here for the red circle. Well, same thing here. I would have to add 85 and 30. That gives me 115. Subtract that from 180, and my red circle is also 65. So when the two of the angles are congruent in one triangle that are congruent to another triangle, then the third angles are also congruent. But do the triangles have to be congruent? And we're taking a look at some right triangles here. They're 30, 60, 90s, and it says, why aren't these triangles congruent? Well, they're not congruent because their sides are different lengths. Congruent has to be same size and same shape. So what do we call these angles even though they have congruent angles? Well, we call these shapes similar. So how do we prove that two triangles really are congruent? If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So here, instead of having to prove all three sides are congruent and all three angles are congruent, we can use a combination of the sides and angles, and in this case, angle, side, angle. So it kind of goes in that order. You have an angle, then you have a side, then you have an angle, and it has to correspond to the other triangle. So it has to have the same angle, the same side, and the same angle in that order to be congruent. So we can only use three of the objects. We can use two of the angles and a side in that order: angle, side, angle. Next one is angles, angle, side, which is a special case of the angle, side angle. If two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the other triangle, then the triangles are congruent. So we could have two angles in a row, but that side has to be corresponding to one of the angles. So I could see that angle C here is corresponding with the side AB. So that means that in the other triangle, it has to be that same non-included side. It has to be the side across from the same angle in the first triangle. So this is angle, angle, side. And again, it goes in that order: angle, angle, side. Okay, our next one is side, angle, side. If in two triangles included, if in two triangles, two sides and the included angle of one are congruent to two sides in the included angle of the other, then the two triangles are congruent. So again, we have side, angle, side. So here's my first side. Here's the angle, and it's included, which means it's between the two sides. And then here's our second side, AB. And that has to correspond with the sides and angles of the second triangle. So DF has to correspond with AC, angle D has to correspond with angle A, and DE has to correspond with AB, so that they both have side, angle, side. Okay, our last one is side, side, side. So in two triangles, if we have three sides of one triangle are congruent to the three sides of the other, then the two triangles are congruent. So you can see that we have the three sides are congruent to the three sides in the other triangle. So those have to be corresponding and they have to be congruent. Side, side, side. These next theorems are based on the previous ones, except they're using the terminology from a right triangle. So if both the hypotenuse and a pair of legs of two right triangles are congruent, then the two triangles are congruent. So here we have the hypotenuse, which is going to represent one of the legs, and then we have the hypotenuse, and then we have another leg, and it has to be a corresponding leg. That has to be the same leg in both triangles. Then the triangles are congruent. If both hypotenuses and a pair of acute angles of two right triangles are congruent to another triangle with the hypotenuse and a pair of acute angles, then the triangles are congruent. This is similar to the angle, angle, side. See, we have the hypotenuse here, which we know is 90 degrees, and then we have another acute angle, and then we have the hypotenuse. So that means that it's going to be congruent with the hypotenuse angle. If both hypotenuses and a pair of acute angles of two right triangles are congruent, if both hypotenuses and a pair of acute angles, then the two triangles are congruent. Okay, this is another variation of angle, angle, side. We can see we have the angle B corresponding to angle E, and angle A corresponding to angle D, and then we have AC corresponding to DF. So that gives us another variation of our angle, angle, side for leg angle. If both pair of legs of two right triangles are congruent, then the two triangles are congruent. So this is based off of our side, angle, side. So if we have the two legs that are congruent, And then we have our right angle here that gives us a side angle side. So leg is similar to our side angle side. So if two legs are congruent in the right triangles, then they're congruent by leg. Okay, so let's see how well we've learned these. We're given the markings on the diagram. Is the pair of triangles congruent by one of the congruency theorems in this lesson? Well, let's see. I've got a side. So this side is marked with 1, and this side is marked once. I have an angle marked, and I have the same angle marked here for angle A, and then I have a side marked with 2 markings, and I have a side marked here with 2 markings. So based on these marks, yes, they are congruent, and they're going to be congruent because I have a side, angle, side. Side, angle, side. Number 2. Given the markings on the diagram, is the pair of triangles congruent by one of the congruency triangles in this lesson? Well, let's see. I have a side, and an angle. And here's the corresponding side, angle. I don't believe we had a side angle, so I cannot definitely tell if these are congruent or not. We did not have a side angle. Given the markings on the diagram, is the pair of triangles congruent by one of the congruency theorems in this lesson? Let's see, I have a side here, and it's marked corresponding here with DB. I have a side marked AC, and I have a corresponding side marked CD. They share BC. Well, that means it's the same side in both triangles, which I could put marks here for the third side. So yes, this would be side. And I can say, what I can say about BC is that it's reflexive, that it equals itself because it's shared in the triangle. Why are the two triangles congruent? Well, let me look at the markings. I have a side, an angle, and a side. I have the corresponding side, angle, and side. So I'm going to say these are congruent by side, angle, side. And what are the corresponding vertices? Let's put the vertices up. Corresponding means they're in the same location. So if I start with angle A, it's marked. So angle D is marked. Those are corresponding. They're the same angles in each triangle. Then I have C and E. So C is across my marked 2 side. So here's my marked 2 side on my green triangle. So across from it is E. So C and E correspond together. And then B and F. Those are the last two. B corresponds with the marking across from it with the single mark. So I need to go to the single mark, and across from it is angle F. So those are corresponding to each other. Why are these two triangles congruent? Well, I see again that they share this side DB. Again, that's going to be reflexive, so that means it's going to be the third side. So I have side. What are the corresponding vertices? Well, if I look at this side marked with the 1, I'm going to look across it, and that's going to be this angle here. So it's going to be angle ABD. Well, I guess they start off with the easy one, A and C. So A is up here at the top, and that corresponds with C at the bottom. And then I get ADB, and that's going to correspond with CDB.